Hey! Welcome to the fourth lesson. In this lesson, we will explore conditional statements and learn how to execute code based on the outcome of a condition. With the help of conditional statements, we can specify a certain condition. Depending on whether this condition is true, we can execute one section of code, and if the condition is false, we can execute another section of code. To describe conditions in the C++ language, a special construct is used, which is written as follows. You use the keyword if to indicate that you are checking something. In other words, if a certain condition is true, you execute a specific piece of code. So, we write the if keyword, then open parentheses, and inside these parentheses, we can write our condition. The condition can be anything. Let's write a simple condition. If 5 greater than 3, then in this case, the code inside the curly braces will be executed. The condition can be read as follows. If 5 is greater than 3, then the code inside the curly braces will be executed. Currently, our condition is so trivial that I suggest not running the program. Let's make the condition a bit more complex. For example, I will create a variable and name it number. I won't set a value for it and will try to let the user input a value from the keyboard. Then, we will check if the value set by the user is greater than 3. If so, the code we write inside the curly braces will be executed. Let's simply display something on the screen. I'll write, the number is greater. Also, let's add a message at the beginning of the program, indicating that the user is expected to enter a number. Great, now let's run our program. Currently, when you run the program, it prompts you to enter a number. Let's try entering a number that is clearly greater than 3. Pressing enter, the message "the number is greater" is displayed on the screen. Why did this happen? Here's the explanation. We asked the user to enter some data. These data went into the number variable. We entered the number 5, and then we checked. If our number is greater than 3, then the message we wrote inside the curly braces was displayed. At the same time, if we try to run the program again and enter a number less than 3, we'll notice that nothing is displayed on the screen. In other words, we received the number, checked it, and found that our number is less than 3. The condition was false, and therefore, this piece of code did not execute, resulting in nothing being displayed on the screen. In summary, conditional constructs are very convenient. They allow you to check certain conditions, and if the condition is true, the code inside the curly braces is executed. If the condition is false, nothing happens. And here, inside the condition, you can check for less than sign. To do this, simply use the less than symbol, which is the angle bracket. You can also check for equal sign. However, it's important to note that to check for equality, you need to use 2 equal signs. If you use only 1 equal sign, it will mean that inside the condition, you are assigning the value 3 to the variable number, and assigning a value is not a condition. Therefore, for equality check, it is mandatory to use 2 equal signs. Then you check if our number is equal to 3, the condition will be satisfied, and this message will be displayed on the screen. For checking inequality, use the exclamation mark followed by the equal sign. So now, if our value is not equal to 3, the condition will be met. Additionally, you can use symbols greater than or less than. Let's run the task and try entering the number 3. We see that the condition is processed correctly. Since we have a check for less than sign or equal sign, this equal sign is triggered. And of course, the condition and its placement depend entirely on you and your program. I also want to note that inside the curly braces, you can write as many lines of code as you need. All of this will work without any problems. In addition to the if condition, you can also append another additional condition. It must be written at the end of the entire conditional statement. It cannot stand alone and is only used in conjunction with the if conditional statement. This additional condition is called else. The essence of the else operator is that everything written inside it will be executed every time your main condition turns out to be false. So currently, without else, our program works like this. If the number we entered from the keyboard is less than or equal to 3, then everything is fine, and the message yes is displayed on the screen. If the number is greater than 3, the program simply does not output anything. Now let's add the else condition. Let's make it so that when entering a number greater than 3, something will be displayed on the screen. Let it be no. So, the program checks the main condition. If this condition is met, this code is executed, and the else block is ignored. If not, the program moves to the else statement and executes it. Let's run the program and test different values. Enter the number 2 to check that the program works. Then enter a number greater than 3 to ensure that the else block is triggered. There you go, our program worked correctly for both cases. In addition to if and else, you can also add additional conditions known as else if. This is an optional additional condition, and you can include it only if necessary. The else if statement is always written after the main if statement and before the else block. In other words, you cannot write else if before the if statement, and you cannot add it at the end, after the else block. Doing so would be considered an error. In my case, I can add it here. Let's write an intermediate condition. If our number is equal to 24, we will display a different message on the screen. Also, note that you can create as many of these additional else if conditions as you need. You can write as many as 100 of them here, and it won't be a problem. Each else if is an additional condition, and this additional condition will only be checked if all the conditions before it turn out to be false. Let's add another variable to our program. It will be a Boolean, and let's name it is happy. Assign the value true to it. I want the first condition to be true when our number is less than or equal to 3, or when our new variable has a value of true. In other words, I want to combine these two conditions here. If either of these two conditions is true, I need to use two vertical bars for combining them. Now we can read it as follows. I'm saying that either the first condition should be true, or the second condition should be true. And then this entire block will be executed. Let's run this code and see what we get. Let's enter a number that is clearly greater than 3. You'll notice that it displayed yes on the screen, even though the first condition is not satisfied. However, the second condition is true, that is, our variable is happy is equal to true. Also, in addition to or, there is another operator. It is written as two ampersands and is pronounced as and. The essence of this operator is that both the first and the second conditions must be true for the entire condition to be true. Only in such a case will the entire condition be considered true. If at least one of the conditions is false, the program will not even check the other one, and the code block will not be executed. Let's run the program again. Let the number be 50. We see that the first condition did not trigger because one of the conditions is false, i.e., 50 is greater than 3. Then, there is an additional check that the entered number is equal to 24. This check also did not pass. Therefore, the else block is executed, and it outputs no. And before we move on, let's pay a little attention to the verification of Boolean variables. Of course, you can always check your Boolean variables in this way. All of this will work correctly, but there are also more concise versions for checking Boolean variables. You can write a condition in this format, but if you simply shorten it to the variable name, it will be the same. In other words, these two notations are equivalent. If I need to check the variable for false, instead of this notation, I can place an exclamation mark in front of the variable, and now I am checking that the variable must have a value of false. Now, let's take a look at another construction called switch case. With this structure, we can check a single variable against multiple possible values. Let's consider this in practice. Let's create a variable and let the user set its value. Then, we'll write a switch case statement. First, we need to write switch, then open parentheses and specify the variable we will be checking. I will be checking a variable called number. Here, you can only check one variable at a time. Next, we must open curly braces, and within these braces, we can write different cases, which are different matching options. For example, if our number variable is equal to 5, then in that case, let's display number is 5 on the screen. Also, at the end of each case, be sure to add the keyword break. With this keyword, you indicate that at this point, your condition is complete. Now we have a simple switch case where we check the number variable. For now, we are checking only for the number 5. If the user enters 5, the code after the colon will be executed until it reaches the break statement. Currently, I have only one line of code, but you can add as many lines as you want. These lines of code will only be executed when the user enters the number 5. It's worth noting that you cannot check for greater than, less than, or equal in switch case. Here, in switch case, you always check for an exact match. And, of course, no one creates a switch case to check a number for just one match. Usually, switch case is used when a variable can have multiple possible values. You can duplicate and modify values to check for other numbers. Additionally, there is an optional operator usually written at the very end called default. It is somewhat similar to the else statement. It works as follows: if all case statements turn out to be false, the default case will be executed. It works just like the else operator and is not mandatory. Now I suggest you solve a task related to today's topic, and in the next lesson, we will go through its solution. If you enjoyed this lesson, don't forget to subscribe to the channel. Thank you all, that's all for me. Goodbye, everyone.